Okay, so start off a little bit about when they said I would have to do a talk here, I had to have a nickname, and I couldn't think of one, but my daughter pointed to a pretty obvious one. So we pointed here, don't we? Other way, got it. Okay. So, Stellar Sky Lord, I'm actually a landlord at a dark sky site that we have out in Mason County. So some friends and I got together and got about 5 acres. And after about 6 years now, we have 19 observatories out there, and 3 in progress, and that'll fill us up. These are roll-off roof observatories. If you see, oops, get a handle here. See the little structures out there, the roofs roll off and open the observatory to the sky. Most of our members out there are actually remote, so they're living in 6 different U.S. states. They internet in, and most of those are either collecting science data or more likely taking pictures, doing astrophotography. We have about 3 or 4 of the members that are visual astronomers, and so we've had a pretty good time setting that place up. So when we talk about amateur astronomers, they kind of follow 2 paths. Once you get beyond being an armchair enthusiast, if you want to get out and really become intimate with the sky and familiarize yourself with what's in the heavens, you become what's a visual astronomer, and they really like to collect the deep sky objects, photons, directly on the eye and process it with the brain and enjoy it. So we have a visual observer out at Stellar Skies, and this is a peek at his observatory. He's got a nice 25-inch Dob there, and looks like he's looking off to the right of Sirius up there, so maybe M47. It's a nice kind of empty observatory, not much to it. You need a lot of room to swing that big telescope around. It also looks kind of lonely, but that's because it's quiet out there, and if you were to take that telescope to a star party, it would be pretty popular, I believe. So the other branch that a lot of amateurs take is we call them imagers, basically, and it's mostly the guys that are kind of gearheads, and they really they just kind of get sucked into astrophotography. Some of them are actually collecting science data for variable star studies and things like this, but this is a typical observatory for one of our astrophotographers, and you can see it's a lot more crowded with stuff. 3 nice telescopes in there. It has climate control, it has network switches and redundant power supplies, a smart roof controller, a weather station, and a lot of equipment. So it's a kind of a different branch from the other. This is a look inside that same observatory with the roof closed there. Again, all that insulation, this guy likes to keep his electronics nice and chill. So he's got it well insulated. So you notice the pretty massive stands that the scopes are on here. They don't want any vibrations messing with the data that they're collecting, so a sturdy foundation is real important for the telescopes there. But anyway, I guess the key thing here is if you get bit by the astrophotography bug, you can end up like this. And the way I like to equate, I'm going to talk a lot about price here. The cost of things is bass boats. So this is about 0.75 of a top-end bass boat here, probably invested in all of this equipment. So if you're talking with your partner about what hobby you could be investing in, well, I could do this or I could do bass boats. Okay, so that's enough about Stellar Skies. Now, you don't want to start out at that level, so let's go back to the beginning. And we get a lot of questions about beginning telescopes for kids or for grown-ups that just want to get started in the hobby and what makes sense to get. And one of the first things we want to tell you is telescopes to avoid. So all 4 of these telescopes are sold by Orion Telescopes, which is a very good company with a lot of great stuff, but they will also sell at the low end and sell some pretty shoddy stuff. And so that's the stuff you want to avoid. So anything with a tripod on it and your budget being $200, you really need to be spending $200 on a tripod just to have a sturdy one to hold your scope. So When they get down into this price range, these get to be pretty rickety. And we'll come back at some detail in the slide in a second, but the two on the right, that is a little compact Dobsonian telescope that is very simple to use, very sturdy, very stable, and it works very well for kids, less sub-teenagers, I guess, and can come up to a 6-inch size. That's a 4-inch scope there. These aren't to scale. That's only a 3-inch scope there. But I know some guys that have been in the business a long time that use the 6-inch version of this because it's a good grab-and-go scope. We want folks to have a scope that they can grab and run off with it and observe without worrying too much about setup time and things like that. Okay, so a little diversion here. If your budget is $200, you might want to seriously consider getting a good pair of binoculars. You can really get excellent astronomical binoculars on that budget. This is a pair of 70 millimeters, which are actually, these are as big in diameter as the little refractor we saw on the previous slide, and you get 2 of them, and it's in a handheld package. And it gives you a much wider view of the sky. You're going to have a lot more fun, I guarantee you, with a pair of binoculars like that than you will with a little stretched out refractor that's on a wobbly stand. Okay. So you don't have to start out. These are actually 70 millimeters is about the largest you can comfortably handhold for a small time if you get a lightweight version. And the 11X is kind of pushing it on the amount of power that you would use in a handheld. But you can put these on a substantial tripod with this is a parallelogram stand there to hold the binoculars. And I know a lot of people that are well into their observing years that use a rig similar to this. Is just a nice sturdy stand with a good pair of binoculars, and they get all the observing time they like in that. So definitely consider a pair of binoculars if that's your budget. So I want to just do a little bit of nomenclature here, what things we're talking about, some of the components of the telescope. So first of all, just types of telescopes real quick. So this is a reflector, and it has a mirror in the back that collects the starlight, and a small mirror in the front that kicks the light out the side. And the stuff that are circling blue in all these telescopes are the eyepiece, which magnifies the view that the mirror gives you. And eyepieces are interchangeable, kind of like if you have a camera with interchangeable lenses. If you want to more power, you change your lens out. So with a telescope, you have a set of these eyepieces to give you different magnifications and different fields of view. So here we have a refractor. It has a set of lenses in the front and a hollow tube and a little thing called a diagonal in the back, which kicks the light out at a 90-degree angle so you don't break your neck if you're trying to look straight up. And then the eyepiece there. And the mounts are circled in red. So the simplest type of mount is what we call an alt-azimuth, for altitude and azimuth, and an alt-az, and it's basically just a fancy way of saying that that telescope can move side to side and up and down in altitude and side to side in azimuth. Now this mount here is more complex. It's called an equatorial mount, and the big advantage of that is that when you set it up right, you can put your telescope on a star or planet, and it only takes one motion to follow that across the sky. So it actually gets in sync with the Earth, and you can follow it. It's a little more complex to set up and manage, so maybe not the best thing for sub-teenagers, but definitely if you're going to go astrophotography, a mount like that will simplify things for you. And the mounts on these guys are also alt-az, so up and down and side to side. And the side to side is provided by a little lazy Susan structure down here. So you can spin them around and around all day if you want to. And these scopes are reflectors as well, with mirrors back there, another mirror up here, and eyepieces. They're very compact, and they have they're shorter, which gives them a wider field of view than a longer reflector like that. And these are excellent, easy to use, easy to set up. You just can go to town with those. On the top of all of these scopes is a little structure that's basically the aiming device, which we call the finder. And that can be a small telescope in itself. It has a wider field of view. You use those to help you find your way around the sky and to aim it at your targets. And we'll talk a little bit later about what we recommend in those, because it can make a difference in how you hunt things. Okay, so what if you have a little bit more money to spend? Okay, this is a tale of two little refractors here. So first note that this is sitting on a very solid mount. It's all steel. The mount's steel, some aluminum saddle plates, but the two refractors there are going to be rock steady on a mount like this. They're not going to wobble on you. So what we have here is a 3-inch telescope, and over here we have a 5-inch telescope. And when I talk about inches and telescopes, I'm talking about the diameter of the lens if it's a refractor, and if it's a reflector, it's the diameter of the mirror. And we call that the primary or the objective of these instruments. And we call that, that diameter is the aperture. So we'll always be talking about aperture of telescopes. The larger the aperture, the more light it gathers, and also the more resolution you get, the finer detail you can see. So you definitely like aperture, but it's not always the end and be all. So I just want to point out that the 5-inch telescope here sells for about $300, and the 3-inch telescope here sells for about $800. And so what's going on there? What's the differential there? It's mostly in the design of the objective lenses here. This one uses special glasses, and the lenses are ground to very high precision and polish. This has a cheaper set of glasses, and basically the main difference is you get sharper images with this, and this one works fine at low power and wide field of view, but when you put high power on a bright star or a planet, you're going to get an annoying purple fringe. So as long as you're not dead set on looking at planets, this is an excellent scope at $300 to cruise the Milky Way, and you can see some astounding views through a scope like that. Now, ranging up a little more, I'll just point out that this $300 telescope with 5 inches, if you put the same kind of glass and design into that, then you'd be talking about a $3,000 telescope, just based on the superior glass. Also in refractors, 5 inches is getting pretty large. Most amateurs top out at about a 6-inch on an expensive refractor, but with the top end glass, adding an inch to that takes it from 3,000 to 6,000. And so every once in a while, somebody will show up at a star party with a 7-incher, and everybody will go, wow, because it goes up exponentially in price for your aperture there. Okay. And this real quick is just a back-end view of those same telescopes. So I'll just point out that the focuser, which moves the diagonal in and out to focus, this one has a much nicer one. This one is adequate, but not so nice. That's also part of the cost there. And usually high-end telescopes will have high-end focusers. These both have big, fat 2-inch eyepieces, which give you a really nice wide field of view. This one has a little finder on the side. This one doesn't. It's got such a wide field of view that you can use it as its own finder. Okay, so there's one other important class of telescopes that we should talk about here, and I call it a trash can scope just because of the shape of the scope. I mean, it kind of looks like a big trash can, really. This is a compound telescope, or we would call it catadioptric, and it uses a combination of lenses and mirrors. So you can see this big lens in the front. It's also holding a little mirror here, and it has the big mirror in the back that collects the light. And it folds up the light path, and there's a hole in the back mirror, so the light comes out of the back mirror to the diagonal in the eyepiece here. But it allows you to put a big long focal length telescope in a small package. If this is a 12-inch telescope, lots of aperture. If this were a refractor, it would be 10 feet long. So that's how much that can compact it. These telescopes, they're different designs in this form factor, but they go down to, I would say, a 5-inch scope is about a little larger than a quart jar and would fit in a backpack. And they make smaller ones, but I would not go below about a 5-inch in that. And they go up to 12, 14 is a popular size, 16 is an observatory size. The largest one I know of around here, a guy in Austin has a 27-inch plane wave. That's about 2.5 bass boats. This one is one I purchased in 2003. At the time, it was the mount and the telescope as a package was about $3,500. Today, they have replaced it with a better design, so they're going more like $5,000. There is a good secondary market for used telescopes. So the places you want to check are astromart.com or cloudynights.com. Or if you know what you're doing or you have access to somebody who knows what they're doing, you can get good deals on eBay as well. A lot of stuff, a lot of obscure stuff kind of shows up there, so you need somebody that really knows what they're doing to know if you're getting a good deal. Okay, so the scopes can go up and up and up in size, and as the aperture increases, you get more light gathering, you get to see dimmer stars, go deeper for the faint fuzzies. You really can get some spectacular views of nebula and star clusters, and it invokes a condition we call aperture fever, which some people say you should never look through a telescope you're not willing to pay for as the aperture goes up, because it'll spoil you. All right, a little more back to earth and beginning scopes. This is an 8-inch on a Dobsonian Altaz mount. So again, lazy Susan down here, up and down here. So 8 inches is a good sized telescope for starting to get into some of the deep sky objects. This is the package that the AAS has put together for our loaner scope program. And if you join up, we can outfit you with a package like that and let you have it for 4 months, get a good chance to play with it. We've done some nice upgrades to it, so it has this big fat 2-inch eyepiece here that gives you a nice wide field of view, and it makes it a lot easier to find things. We put the finder on it here. We supply you with a sky atlas. We don't give you this adjustable observing chair, but I highly recommend one of those. You can sit down low or up high as you need to as a scope, but you kind of I put it in there just to give you a scale for about, how big this is. So one step down is a 6-inch and one step up is a 10-inch. The basic scope itself, if you were to order it from Orion, would be about $400. We doubled the price of the package by putting in 2 really good eyepieces in there. And I think it's the best way to get more bang for the buck out of a telescope like this is to upgrade the eyepieces. And in fact, I can even recommend, if you have a scope that's got the default set of eyepieces, that if you go and look at these AstroTech Paradigm series, those are excellent eyepieces. The price is right, $60 each. Get one at a time or build yourself a set. They give you a very nice wide field of view, and they're very, very, very crisp, and it's an excellent upgrade to a small telescope. Okay, another piece of equipment that's crucial is for finding your way around the sky is what kind of finder are you going to use. And it could be another small telescope, but we recommend these reflex sights. So one of the best is called a Telrad. And what it does is it has a little window there that you look through, so you can see the sky behind it. You see the moon right there. And if you can see a star, then you can put a bullseye on it because it projects a red bullseye into the sky. And it's 3 concentric circles. The smallest one is 1/2 degree across, then 2 degrees across, and then 1 degree across and 2 degrees across. And using that, you can get a star atlas and just kind of map your way across to find things, what we call star hopping, all over the sky. Now, a simpler version is just what we call a red dot finder, and it just projects 1 red dot on the sky. But if you can see a star or see a planet, you can line it up with that red dot just by moving your scope there. And once it's lined up, you've got it in your eyepiece and you're good to go. So highly recommend a good finder on your scope. And just as for star atlases, what I'm giving you here is a piece of free advice. Just get this one. There's not really a better one for beginners, and once you've used this for a few years, there are plenty of upgrade options if you want more detailed sky atlases. But this one has stars down to about, I think, 7.5 magnitude, so dimmer than you can see, but useful for helping you star hop. And star hop is just a case of starting out with a place, something you can see and you know, like the star Merak here, and you find that in Andromeda, and those 3 stars will lead you right to the Andromeda galaxy, or you can use Cassiopeia up here in this triangle, kind of points to it, but misses it a little bit. So there are different strategies for hunting things down. You can also get a gizmo that you see down here that will put these telerad circles on your atlas, and you can use those to step off different distances in your atlas to find things. So very highly recommend to start with an atlas of good quality. Okay, switch gears real quick. Another thing you should consider is just getting a device to hold your smartphone. This is something that kind of is a new phenomena for us, but we'll be giving star parties and everybody wants to hold their smartphone up and get a picture through the eyepiece, which you can do, but it's very, very hard to line it up and hold it steady by hand. I know a guy who can do, he's practiced it so much, he can take excellent pictures without it. But these devices make it very easy to just let the camera sit there. And the cameras are so smart these days, you can even avoid the vibration of pushing on it to trip the shutter. Just use your voice, say snap, and you'll get a nice picture without vibration. So a couple of different styles here. This is from a company called AoTATX, and it has a built-in eyepiece. And this one clamps on to whatever eyepiece you already have. This is from Orion. It's called a SteadyPix. And those devices will help you get into astrophotography I mean, you've already got the phone, so take the next step. This is an example of some images taken in this manner. So this is a very large image of Jupiter by a handheld camera. Or, I don't know if he did it handheld or SteadyPix, actually. But you know, it's pretty impressive for just holding a camera up to an eyepiece to get an image like that. That's a pretty standard moon. I'm sure that one was handheld, but that's typical of what you can do with these kind of cameras, just holding it up to the eyepiece. The next step, if you want to take it in astrophotography, is to use one of the consumer cameras out there. You can use your digital SLR, but those are being replaced now by mirrorless cameras, which is what the Sony A7S II is. And what you do there is just basically take the lens off, and you use an adapter kit, and that will plug right into your focuser on your telescope. Or you can put an eyepiece in this little guy and get a magnified view. This is a picture of the Andromeda galaxy, and the thing that's amazing to me, it's only 13 seconds of exposure. And usually people take many, many minutes to get a picture of that density of Andromeda. It just shows that these cameras are getting more and more sensitive as time goes by. Rob Pettingill's got one of these cameras, and I'm trying to get my hands on one to play with it too. But that's a sample of what you can do with this type of photography. And that's about as far as we'll go in astrophotography. So turn for a minute to software. And I know I talked about a paper star atlas, but you can also get a software one now, and it'll play right on your phone or tablet, and it has a lot more features than a paper atlas does. You can zoom in and out infinitely. There's just so many things. These two are our favorites. Sky Safari, as Don mentioned, we have a club member who's the main designer of that application. And it has like 3 versions on it, and I think the most expensive one has a gazillion stars for like $40, although it always goes on sale to half price. The middle version, the Plus, is just fine. Another thing that these programs can do is if you put a go-to device on your telescope, and motors on the telescope, then it's pretty easy to hook a device like this up. And with voice control now that they're touting here, you can say, you know, Siri, find me the Andromeda Galaxy, and boom, there it goes. It's going to go for it. It'll also put a map of the sky up, and as you move your telescope around, a little cursor on the sky will follow it. So you can just watch your phone and steer your telescope to whatever you're looking at. We call that push to instead of go to, but it's another very valid way of finding things in the sky. Sky Safari is pretty much, it's available on Android, but it's kind of got a bias for Macs. It runs on Mac OS. Stellarium runs on everything under the sun, and it's particularly good implementation in Windows. They both have a lot of features in common. One thing Sky Safari's got right now that Stellarium doesn't is a good system for giving you observing lists, things to go find, and then recording your observations. And we're very big on when you see things, write down you know, what you're seeing and keep a log of that. Sky Safari with the voice control, I'm waiting for, I'm lousy at taking notes, but I can talk up a storm sometimes, so it would be a good note-taking device for me. I'm waiting to get there. All right. Everything else you want to know about mobile apps in astronomy, just go to this site. Go to space.com, and for the author list of Chris Vaughn, and he's done about 2 years, about every 2 weeks, doing an article on what new piece of astronomy software is out there for mobile apps or even PCs on occasion. So there's just tons of stuff, and it's really, some of it gets pretty esoteric. Yeah, just cruise that, and it'll give you tips on, you know, how to get good pictures with your smartphone or other methods, and just about anything you can think of. Okay, this is just a picture comparing Sky Safari to Stellarium. This is the mobile version of Stellarium. It looks a little different than the PC-based version. This one is more what I call photorealistic. This one, the dimmer stars just turn into little dots, and if you take each of these apps and zoom in from here, you really, I think this one holds the detail better, and this one gets more abstract as you go in. This one also kind of, to me, it looks like the view you see in a reflector with slightly fatter stars, and this is more like a refractor, which kind of gives you tighter stars if it's got the good glass. Okay. Oh, okay, we're kind of already at the end here. The most important instruments you have, you already have them. Please take care of them, and they'll do you a lifetime of service. The key takeaways from your eyes as instruments is a couple of concepts to learn are called dark adaptation and averted vision. Dark adaptation is you got to get in the dark and stay away from the light, and your eyes will get more and more and more sensitive. That process will go on for up to an hour, and at the end of an hour they are something like 10,000 times more sensitive than they were when you were inside with room lights. And if somebody shines a white light in your eye, you lose it all, and you got to go start all over again. So amateur astronomers are big on their red flashlights. We use red light because it preserves your dark adaptation. And there's probably a red light industry almost as big as as a smartphone industry. One thing though, when you're on Amazon and you want to buy a red flashlight, make sure the light is red, not just the flashlight, because they love to sell you a red flashlight. Okay. I have a list of references that's longer than this printed out. I've got about 20 copies if anybody wants to look into some more details about what we talked about. And that was just one thing I didn't think would make the main page, but it is a web app for telling you exactly what the weather is going to be at a certain place. It tells you what the cloud cover is, how clear the sky is, and how steady the air is. Wind and temperature and humidity are all important. So if you've got a dark sky site, you can register it on this site, And you'll always know, when you see all dark blue bars across the top, you hop in the car and you drive out. It's that simple. Okay. That's all I've got, folks.
All right, so I don't think we have any Twitter questions, so I actually have a question. So I typically use different kinds of telescopes than these, but I did bring my personal telescope, and I was wondering if you thought this would work for what you're talking about.
Well, it's very portable and grab and go,
I came prepared.
Yeah, and you never know when something brilliant's going to flash across the sky. You pull it out, you're ready. Yeah.
All right.
You won't get aperture fever over that one, but.
At least it functions. I'll throw that out there. All right, do we have any questions from the audience? Right here in front.
Well, I did check on that.
Thank you.
And you can get a derelict used bass boat for $2,500. You can get a starter bass boat for about $15,000. You can get a really good bass boat for $45,000, and there's some top-end ones at about $70,000.
So which unit were you using?
I'm sorry?
The 70,000 bass boat?
Oh, I meant to say, let's see, top-end TEBB. Yeah, top-end bass boat. So that was the one I was thinking about there.
Well, we do love our acronyms. Okay, so we do have a Twitter question that just came in. So if this person has money, should they invest in a larger mirror, accessories, go into computer-based tracking, or what is the most important?
Very good question. First thing I'd say is probably I'm not going to be able to give you a satisfactory answer in a short time here, so come to one of our star parties. And we'll have samples of all of these telescopes, and everybody be glad to kind of go over those details with you. All things being equal, aperture is going to do you the most good, but it's also going to raise the price the fastest. I would say focus on especially if you're starting out, focus on a medium-sized telescope. Get a really good set of eyepieces with it. And by medium, I mean could be 6, 8, or 10 inches, or if you want to stay with a refractor, 4 and 5 inch. And you don't have to buy the expensive glass, the acromats. You can have a lot of fun with those without spending a ton of money. But get a good set of wide-angle eyepieces, let you see more of the sky, make things easier to find. And especially if it's a reflector, you really do need one of those pointing devices to help you. So go to. Well, it kind of is a philosophical thing. We're very big into learning the sky and becoming intimate with the sky, and that means not relying on artificial means to get you there. So it's using your wiles and your memory and other skills, and it's kind of you can impress your friends if you memorize where these things are, and you can point your scope up there in seconds while he hadn't even punched in his go-to coordinates yet. How did you do that? Well, I've been looking at it for 30 years. I know where it is.
I will say that is one thing you guys do much better than any of us. I don't know any of the constellations. I'm sorry to disappoint you. Sorry. I can't tell you what that is in the sky. Sorry. Okay, one more Twitter question. What is the most important investment you've made in observing, and what would you recommend?
The most important investment in what? To observe. Well, I bought a 20-inch Obsession. That's a brand of telescope. 25-inch, excuse me. And I've had a real good time with that. Again, you almost need to sit down with somebody and have a long conversation. I'm sorry I can't give you a pat answer on that. It depends on you and what you think you'd like to do. And maybe you need to get a little experience looking at the sky too to say, well, I'd like to find those kind of objects. So again, come to our star parties.
All right, let's thank our second speaker. Again, if you are interested in talking to them more, if you have a very specific question, if you just want to look through some of their fancy telescopes, go check out their website. Before we break for intermission, I would like to invite up to the stage a very special guest. So the current president of the Austin Astronomical Society is here. Get up here, come on. And I know a lot of your members have been up here and have been giving talks today, but I would also like to make you a space cadet.
Aww.
So we've come up with a name badge for you.
Oh, I know who's behind this.
Yeah, so we had one of your members give you a nickname, since we all have very fun, very clever nicknames. Yours is Scruffy-Looking Nerd Herder.
My wife thinks I'm a very handsome man.
That's all that matters.
That's all that matters. Thank you very much.
All right, so I just wanted to thank you for your support. So that's for you.
My pleasure. Thank you very much. Hey, I do want to say Terry was being very humble when he was asked the most important investment that you can make. I would say that probably better than anybody that I know in a lot of years of astronomy, Terry knows the sky better than any astronomer that I'm aware of. He knows how to find almost anything that you would want to look at in the sky. And I would say if he were less humble, he would say spend your time getting out and looking up and learning the sky. And the most important thing is if you want to start learning how to do this is to do it. So thank you very much, Terry. I really want to thank all of you, and I want to thank Astronomy on Tap for being so welcoming to us as Austin Astronomical Society and really making us feel at home and also helping us celebrate our 50th birthday. That's really kind of a big deal. And I don't know of anybody else who's been able to hold something together for this long and make it so special. So thank you guys very much for your time, for sharing this space with us tonight. And what I would really like to do tonight, though, is the Austrian Astronomical Society, one of our main things that we like to do is we want to promote the education and advancement of astronomy and helping to support people that want to learn about what we do and what we care about and what our passion is. And we support very few groups, but we support the Astronomy League and the International Dark Sky Association. And tonight, we've always had a really nice, long-standing relationship and friendship with Astronomy on Tap. But we're just so impressed with what you guys do. I mean, where else can we go and learn so much about science and have so much fun learning about astronomy and access to some really fine craft beers? And really, where could I go and wear this shirt and my wife doesn't roll her eyes when I leave the house? I mean, this is really pretty amazing. But you guys are awesome. We love what you do. And I would really just like, on behalf of our little club, I would like to give you guys this little bit of financial support and love. So thank you guys very much.
Again, I cannot begin to explain to you how much time we all invest of our own will into making this show happen for you every month. And it's incredibly important to have fans who come every single month and encourage us to keep doing this. And so having the financial support to keep this going means a lot to us. And I appreciate that you're always here and you wear a shirt like that and we'll put you on stage. So,
Awesome.
So we have one more thing. You said it was your 50th anniversary today?
It is, yes.
Okay. So Jim is fairly new to the presidency. He was elected in June, so it's just been a few months here. But I'm going to ask you to represent the entirety of our, I believe we're almost at 500 members, in accepting this proclamation. Be it known that whereas the Austin Astronomical Society is a nonprofit organization run by volunteers with the purposes of securing the pleasures and benefits of an association of persons interested in amateur astronomy, blah, 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 blah,
Yada, yada,
yada,
yada.
yada, yada. Whereas to date, it is estimated the Austin Astronomical Society has brought the wonders of space and the night sky to over 500,000 individuals in the Austin metropolitan area. Whereas August 20th, 2019 is the official 50th anniversary. Therefore, as says here, I, Steve Adler, Mayor of the City of Austin of Texas, do hereby proclaim August 20th, 2019 as the Austin Astronomical Society's 50th anniversary day.
Wonderful. Thanks, everybody, very much. Thanks for letting us take over. We've got another great speaker a little bit later. In astronomy, one of the greatest greetings or farewells we can give to each other is clear skies, and that's what I wish to all of you. Thank you very much.